Now we have to start with lecture number 5 of classical mechanics. We are studying for the Newtonian mechanics under classical mechanics, in which we started with the introduction of classical mechanics and mechanics, and differentiated between the classical and quantum mechanics, and studied that mechanics is associated with the motion of the particles, and in motion there are two kinds of the motions, that is kinematics and dynamics. In kinematics, that is the motion in which the object is observed as it is in motion, but in dynamics the cause of the motion is also observed. And then we discussed for that motion there are some reference frame of reference, as there is relative motion always. So there are two kinds of frame of reference. First one is inertial frame of reference and the second is non-inertial frame of reference, in which we discussed about some examples of inertial and non-inertial frame of reference. Further, uh, explaining with different examples, we understood about the frame of reference that is very necessary in the Newtonian mechanics. After that, uh, also in that we discussed that for the frame of reference, uh, there are some conditions. There must be an observer and a place of act where the working is being done. Further, we discussed about the the Newton's first law, and with some examples we discussed second law and then third law. After that, we discussed about the work energy principle and different definitions for the conservative system force. We know that there is a single particle and also a number of particles, system of particles. Same effects are observed on the system of particles. And then we discussed about the external and internal forces acting on the system. Now we are going to work with the equation of motion of the system of particles. So in this lecture we are going to further explain the equation of motion, converting from a same as for the single particle is also written for the system of particles. Then the equation of motion is explained for the system of particles. Further, then we are going to discuss about the linear momentum of system particles. Afterwards, we will discuss about the conservation of linear momentum of system of particles, and then the conservation of linear momentum for the system of particles. There are some problems regarding that, and after that there are some problems to be discussed, and after that there are some references. इधर आओ, इधर आओ. There are some references at the last. Afterwards, now we're going to uh, start with the equation of motion of the particle, that we know that in Newtonian mechanics that Newton's law are valid. So if there are as we know that there are three Newton's laws. First law is as the object remains at rest, and the object in motion will remain in motion unless and there in any as in any external force applied. And in second law we discussed that force is product of mass and acceleration, or we can say that acceleration it depends upon force and mass. So but in Newton's third law we discussed that action reaction forces are opposite and equal in magnitude. So these are the laws discussed under Newtonian mechanics. Same is the effect observed for the system of particles. If we have a system of particles as number of particles in a one system, then these equations can be written for the system of particles. For this we will first of all consider the same thing we have discussed for the uh, Newton's second law of motion in the form of linear momentum, that is F is equal to dp over dt. Now we apply that to the ith particle. As we discussed that there is a ith particle, considered ith particle effect in a system of particles where one kind of effect is discussed and then applied to the whole system. So here we can write that FIE, that is the external internal force, plus the summation I j is equal to 1 to n FJI, that is the that is the system. So that is the ith particle uh, equation of that is the sum of force for the system of particles for the ith particle. So that is written as FIE plus mission j is equal to 1 to n FJI, and the whole force will be equal to the dpi over dt. That is, I is in subscript, not in multiplication, that is in subscript. So after that we know that the total force, we have discussed previously that total force is sum of external forces and internal forces. Now we can write the momentum, linear momentum value as pi is equal to mvi. Here I is written for the ith particle. Now as we know that dpi over dt is equal to for p is equal to mivi, we substitute the value, and you know that mass is constant, so mi will be written out of the differential dvi over dt. Then that is equal to mi into d by dt, substituting the value of vi, that will become dri over dt. That gives the equation d square r over dt square. Now that is written as in the position vector form, we can write that dpi over dt, that is change of rate of change of linear momentum, that is equal to the equal to mi d square ri over dt square in the position vector form. On the right hand side you can see that the total force will be equal to the sum of two forces, that is the internal force and that is the external force, plus the internal force with the summation for the ith particle for the whole system. Now that we have got this value of dpi over dt, we can substitute in the above equation of FIE plus mission j is equal to 1 to n fji is equal to, in the place of dpi over dt we can substitute mi d square ri over dt square. Substituting this value we will get on the next point. Now as that is a system of particles, नीचे उठा रहे हैं मेरी रिकॉर्डिंग खराब हो रही है, बकवास कुछ कर रही है. Taking the sum over all the particles, the above equation may be written as we are discussing dealing with the summation of particles for the system of particles. So we have to take the summation for whole the system. So after writing the equation, we take the summation on both sides with respect to ith particle, that is equal to summation I mi d square ri over dt square, that is equal to summation I fie plus summation j fji. Now taking the differential d square r over dt square common and making the whole term as mi is constant, so writing inside the differential or outside the differential makes no difference. So making the equation as summation I mi ri is equal to summation I fi plus summation j fji. We know that summation means the sum of the particles, so summation IFI will be the total external force on the system, and summation J will be the total internal forces on the ith particle. So, giving that the question number 1, we have here we can write summation IFI is the total external force FE, and summation J FJI is equal to total internal force. We can write these values in the above equation 1 and we can get the value. You can work out all the process for the system of particles by yourself, writing on a paper, so that there is no difficulty while discussing all the mathematical work for the system of particles to understand. You can see that the whole force which was for the single particle F is equal to dp over dt, then the force for the system of particles will be sum of all the forces, and the all forces are the internal forces, and as well as the internal forces and external forces in this mission form are written. So this equation is equation 1. Substituting the value in the place of summation I fi as fe, and summation I summation j fji as in the place of total internal forces as mission I Fi is simply the total external force which may be represented by Fe. Now it is assumed that Fji obeys Newton's third law. That means the ith particles imply a force of reaction on the jth particles, and jth particles imply a force on the ith particles. So as it is the internal force, that Fgi is the internal force, so for all the internal forces, the ith particles substituting force on the jth particle will same apply the force on the ith particle by the jth particles. That means the total internal force will be cancelled out, it will be in equal and opposite way. So we can write according to Newton's third law, Fji is equal to minus Fij, where the total sum now will be equal to summation I summation j Fij, summation I summation j Fji is equal to, that will become from the above equation Fji plus Fij. That means the first force is the ith particle exerting force on the jth particle, and plus the jth particle exerting force on the ith particle. The whole sum of the all the forces will be equal to 0. Thus, the second term in the above equation 1 will be equal to 0, and the equation of motion then becomes, for the above equation we can write as, then the above equation previous of d square or d square over dt square into summation I m I ri plus summation I summation j summation I summation j fji plus fi e, or summation fi can be written as fe, will be equal to 0, so that the whole force will be equal to the all the external forces. So that will become in equation B as d square over dt square summation I mi ri is equal to Fe. Now to simplifying the right hand side of the left hand side of the equation B, we define a vector R position vector for the center of mass of a position. It means that the number of particles concentrate on a one point of the system of particles, so that will be the center of mass of the whole system, that is represented by capital R position vector. So we can write capital R is equal to mi ri plus m2 r2 over m1 plus m2. That means that is the product of mass and position vector plus second mass of the second particle with the position vector r2 and divided by sum of all the masses. Now as we know that we are dealing with the system of particles, so that we need to write that equation of our capital R in the form of system of particles as a substituting summation. So we can write capital R is equal to summation I mi ri over summation I mi for the whole system, the sum of the all the masses. Now taking the different summation I mi in the division to the right left hand side of the equation, that will become as a product which we can be written as summation I mi into capital R is equal to summation I mi ri. That value of summation I mi ri can be substituted in the place of capital B. So the above equation capital B can be written as d square over dt square into summation I mi into capital R. That means that will be equal to the resultant of all the position vectors of to the center of mass from all the particles in the system, that will be capital R, and summation I mi will be equal to the sum of all the masses. So we're substituting the this value in an above equation B. As we know that summation I mi is the total mass of the system of all the particles in the system, that is represented as capital M. So the above equation will become capital M capital R is equal to summation I mi r I. So substituting this value of equation C in equation B, we get that d square over dt square into mr is equal to Fe. Taking the capital mass out of the differential, as mass is always constant, so we can write md square r over dt square is equal to Fe. Here we can say that small m is converted into capital M. That means that the single particle mass small m is shifted to the capital mass M for the whole system of particles, and that is the summation of all the masses, and small r position vector for a single point particle is converted into the resultant of all the all the vectors from the position vector of all the particles to the center of mass as capital R. So that is equal to Fe. That is the similar equation for the single particle, which is F is equal to dp over dt is equal to m small m d square small r over dt square for the single particle, and similar that equation for the system of particles, it will become Fe is equal to m d square r over dt square, where we can see that total force is no in the total force there is no effect of the internal forces, as they cancel effect of each other, and the whole equation have the effect of only the external force. So that is seen that capital F is E is equal to md square r over md square capital R over dt square. Hence it is the equation of motion for the system of particles. That is the very important equation, so we have, you have to keep it in mind, as we have to use these equations in further lectures. This equation shows that there is no effect of internal force in the motion of the system of particles. As I told you before, that all the particles are exerting force in on each other in equal and opposite direction with the same magnitude, so they cancel each other effect, that is equal to 0. So there is no role of the internal force in the motion of the particle or system of the particle, and the system uh, and the system works and the system works as a whole system but not as a single particle. So by this equation, this means that the entire system moves as if the total external force is acting on the entire mass of the system, as I told you before. So we will consider here that the whole all the system of particles mass is concentrated on a one point, which is the center mass of the system. You have discussed about and studied about the center of mass of the system in the previous class for the center of mass in your chapter of mechanics. Thus, the problem for the system of forces is in converted to that of the single force. Now, as there is no internal forces, there is only one force, that is the external force. So all the forces acting on a system will be converted into a single force, that is the external force. So it also indicates that the purely internal forces have no effect on the motion of the mass, and the system moves as a whole but not as a single particle. Means that a single particle cannot uh, cause any kind of effect in on the motion of the system, but the whole system moves out as a particle system, as a one particle system, to describe its motion from one place to another in the form of Newton's second law. Here we can take the example of the uh, pigeons or sparrows, or uh, in a form of a group flying in the sky. The all the pigeons are the particles and their group is the system, so they travel in a one form group. Now as we discussed for the single particle, that linear momentum of the particle will be conserved, and also the equation for the linear momentum p is equal to mv is for the single particle in a in straight line direction. Then similar is the fact for the system of particles. So for this, for that we can say that all the particles constituting the momentum will be in the form of sum. So we can write linear momentum of the system of particles as it will be equal to sum of linear momentum of the part of all the particles. So that we can write p is equal to p1 plus p2 plus p3 and so on. Now substituting the value of P1, P2, P3, P1 will be equal to M1 V1, P2 will be equal to M2 V2, and P3 will be equal to M3 V3 and so on. So we can write P is equal to M1 V1 plus M2 V2 plus M2 V2 plus M3 V3 plus so on. And for you know that for the sum of all the particles you have to write the summation. So we have to write in the summation form, that will be I is equal to I is equal to 1 to n. uh, so p is equal to summation I is equal to 1 to n m I v I, where v capital vi you can where sorry, where vi is the velocity of all the particles. Now in as we know that in the position vector form the value of vi will be dri over dt. So we can write p is equal to summation I is equal to 1 to n mi dri over dt. With the lecture you can write down all the terms, as we have to use all these terms in the next lectures and topics we are going to cover in classical mechanics. We have written that before, that mass is constant. We can write inside the differential and outside the differential as well. So the equation becomes as p is equal to d by dt summation I m r I r I uh, with the bracket. And then we know that from the previous equation that summation I m I r I means that the sum of all the particles product of mass and position vector, that will be equal to M capital R. So we can write momentum is equal to d over dt into capital M capital R, and that will be become as p capital P is equal to m into d capital R over dt, and that is written as equation A. Here you can see that capital M is the mass of the system of all the particle at the center of mass, and capital R is the position vector of all the particles towards the center of mass, that is the resultant of all the position vectors. After writing this equation, we will discuss that that this momentum for the system of particles will be conserved. So, according to the single particle conservation theorem for the linear momentum of system of particles, if the total external force acting on the system of particle is 0, then the total linear momentum will be conserved. So we can write as p is equal to mdr over dt, and differentiating the above equation p as dp over dt, and on the right hand side that will be become M into d over dt into d over d capital R over dt. So that equation will become dp over dt is equal to capital M into d square over d square into capital R over dt square. So the above we know that dp over dt is equal to fe from the previous equation for the system of particles of equation of motion. So as fe is equal to capital M d square R over dt square, and will become as that will become as dp over dt. Substituting this value in the above equation, Fe will be equal to capital M d square capital R over dt square. As for the linear momentum to be conserved for the system of particles, we have said that the total force acting on the particle should be equal to 0. So we can write Fe is equal to 0. So by substituting this value in above equation, we get as dp over dt is equal to 0. And if we integrate this equation, we get p is equal to constant. From here we can see that the linear momentum is conserved for the single particle, same as well that is conserved for the system of particles. This means that all the laws affecting the single particle are same as affecting the system of particles. Now taking an example problem, drive the relation for torque acting on the system of particles from angular momentum capital L. Here we are going to calculate the torque for the system of particles where the angular momentum is capital L. We have discussed that in the previous lecture that torque is equal to rate of change of angular momentum. So it means that if torque for a single particle is equal to dl over dt, then that must be equal, same should be implemented on the system particles. So solving this problem for the system particles, we have to take we have to take the equation for the system of particles as the angular momentum in the form of summation for the whole system. So capital L is equal to summation I into Ri cross Pi. That you have to keep in mind that these I are for the ith particle and should be written in the subscript. They are not in multiplication. So that the above equation, we have to take solve this above equation to dl over dt should be equal to torque. Now differentiating this above equation dl over dt, we can write dl over dt is equal to n, and that is torque, that is equal to d by dt into summation I ri cross pi. We know that we can apply product rule on the on that, as d by dt into u dot v will be equal to du over dt dot v plus v dot du over dt. So implementing that product rule on that equation on the right hand side, we can write capital N is equal to summation I into dri over dt cross pi plus ri cross dpi over dt. So in the above equation as previous worked out, we can write as dri over dt will be equal to uh, v, and pi will be equal to mivi, and dpi over dt will be equal to force. So that equation will become vi cross mivi. We know that the cross product between the two same vectors is equal to 0, so vi cross vi is equal to 0. So in the, if we, from the above equation we can see that in the place of dri over dt cross pi, we can write as summation I vi cross mivi, and that becomes 0. The first term on the right hand side of the above equation of the torque is equal to 0, so the remaining equation will become omitted from that part of equation. So we can write capital N, that is torque, is equal to Ri cross dpi over dt, and we know that dpi over dt is is equal to the external force Fe. And you know that the total force is sum of all the internal forces and external forces. So the for the system of particles, torque will be equal to summation I into ri cross fie plus summation j into fji. Fi is the external force and summation jfj is the internal force. Now taking the ri cross multiplication with both the terms, ri cross fi plus ri cross summation I fji, solving that equation and taking the summation inside the equation, we can write summation I and capital N is equal to dl over dt is equal to summation I ri cross summation I fie plus summation I ri in cross summation I fj summation ji. That will be written as equation C. Here we can take a system of particles in a two coordinate system xy, where the ith particle is at the position I with the position vector ri, and f this particle j is at the position j with the position vector rj. The ith particle is substituting the force on the jth with the I force fji, and jth particle is substituting the force fij. That is equal and opposite. So the difference between the two position vectors will be rij is equal to ri minus rj. So that can be written as ri cross fji plus fj plus ri cross fij. And from the above, we know that the force is equal and opposite. So f uh, Ij is equal to minus Fji, that is will be equal to Ri cross Fji minus Rj cross Fji. So taking the Fji common, we have Ri minus Rj, and that is equal to Rij cross Fji. And we know that the two equal and opposite forces are in same in magnitude and different in direction. Now substituting this value, capital M is equal to dl over dt. We have Ri minus Rj is equal to Rij. So Rij cross Fi Ji is equal to 0. Putting this value in equation C, the above equation becomes as capital N is equal to dl over dt is equal to summation I into Ri cross Fie plus 0. So that equation will be given written as now capital N, that is torque, is equal to dl over dt into summation I into Ri cross Fie. And you have to keep in mind that these i's and e are in subscript. So uh, here summation ri small will be equal to capital R, and summation I Fie will be equal to Fe. So where that can be written as capital N is equal to R cross Fe, and here torque is represented as capital N, and we know that torque is equal to R cross F. R is the momentum and F is the force. So here for the system particle, same is the equation for the torque, capital N is equal to R cross Fe. That gives the total torque of the system of particles due to the external force. So here also we can see that there is no effect of the internal forces in the system. Here you can see that though both the equations for the system of particles and for the single particle is the same. So now we are going to solve some examples. Number one is that prove that the gravitational field is a conservative field with the position vector small r. There is the value of small r. From this we have to solve the find the value of velocity v, acceleration a, momentum v, and force F. We know that for this you know that velocity is equal to dr over dt, so you have the value of position vector r, that from here you can calculate the value of dr over dt, that will be give to you the velocity value of v. After getting the value of v you can calculate the value of acceleration. You know that acceleration can be calculated as dv over dt. You can calculate that from also from the value of v, that will give dv over dt, and you can also use the value of position vector r, that is d square r over dt square. Also from this you can calculate the acceleration. Both are the same processes. With those same processes will be give the two different way of working out will give you the same result. Now that calculating the momentum, for that you have mv, and as you know that mass is the small m, you can write as it is, and substituting the value of v, multiply you have got from the previous equation, multiply that with the mass m, yeah, you will get the value of p. And after for now to calculate the force F, same easy work as F is equal to ma. You can calculate this from equation for using the position vector r. You can also find the value of F, that is F is equal to m into d square r over dt square. uh, you have to that solve that problem by yourself and show me your results. Discuss with me. Now the second one is prove that the electrostatic force is conservative field. You know that gravitational field of force is conservative, similar as the electrostatic force is conservative field. It means that the total work done in the closed path will be equal to zero. So you have the electrostatic force of equation F is equal to k m1 m2 over r square. So solve for this, you have to calculate the conservative field. For conserve to conserve, we have studied that the curl of the force means that del cross F should be equal to 0. So you have to you have the force, electrostatic force, and you have to multiply with you have to take a cross product with force. Also you have to solve it by yourself and discuss the result with me. I hope you have noted down that. Now for the fourth problem, that you have to show that kinetic energy can be expressed as the sum of kinetic energy of the motion of center of mass and the kinetic energy of the motion about the center of mass. It means that there is the kinetic energy sum of two mm, sum of energy of two kinds, that is the center of mass of the kinetic energy and kinetic energy at about center of mass. After solving this, show me your results and discuss with me. Another problem is consider a particles of system of n particles in a uniform gravitational field. Prove that the total gravitational torque about the center of mass cm is 0. We have to calculate that gravitational torque about the center of mass, or you can see the rotational torque is equal to 0 at the center of mass. You have to calculate these solve these all the four five problems and discuss the results with me. If there is any kind of difficulty you can ask me. These are all the results from the previous lectures we have studied for the kinetic energy, and how to conserve a field in a closed path. All the results or equations are have been discussed previously, so you can use them in solving these problems. If there is any kind of difficulty you can ask me. And then I will tell you the results to verify your result you have solved which you have solved by yourself. Note down all the 5 problems and solve them. Now these are the references for the classical mechanics we are following um, for your lecture class of BS 5th. To solve the problems or understand the topic, if there is any kind of difficulty, you can have a help from these books. The most referred book of classical mechanics is Goldstein to follow. Hopefully there you have understood all the topic. If there is any difficulty regarding your topic or the solving the mathematical work, you can ask me. I will discuss all the problems with you and let you understand the mathematical work for the classical mechanics, the terms used in it, and these all the terms are further being used in the further work of the classical mechanics, so you must understand it with completely. So there should not be uh, any kind of problem in it, because by this you are going to work further. If you have any kind of flaw in or in understanding this lecture or previous lecture, I will be very grateful if you ask me your questions and discuss with me. After noting down the references of your books, you can also which form you can also follow the YouTube links as well if there is any problem in regarding understanding this. Thank you. uh, Thank you for this and having a discussion with me. Thank you.